Hi everyone, welcome to lesson 2 of the Python learning series. In this lesson, we are going to learn about constants, variables, expressions and literals in Python. That is, we are going to learn how to declare and use constants, variables, expressions, statements and what is the meaning of literals in Python. So let's get started. So now we are in Python command line, also called as a Python shell. First, let's learn about constants. What is the meaning of a constant? Constant is nothing but any fixed value whose value does not change is called as a constant. So it can be a number or it can be a letter or it can be a string. String is nothing but a sequence of characters. Say for example, if I say print 678, here 678 is a constant. If I say print 87.4, here 87.4 is a constant. If I say print hello world, here hello world is a string constant. So constant is nothing but a fixed value whose value is not going to change. Its value is going to remain the same. The next one is variable. What is the meaning of a variable? Variable is nothing but a named location in memory which is used to store the data. That is, we are going to name the memory location which is going to hold the data. We are going to give a name to the variable. And in Python, variable names can start with lowercase letters or uppercase letters or underscore character. No other special character is allowed to begin a variable name in Python. And it can have a mix of letters, numbers, and underscore characters. And one more thing to remember is reserved words, also called as keywords, cannot be used as variable names in Python. Say, for example, you have if, you have else if, you have raise, assert, in, global, finally, lambda. These are all examples of some keywords in Python, and you cannot use them as variable names in Python. Let's see some standard ways of defining variable names. I can define a variable name like this. Underscore a is equal to 8. Here, I'm defining a variable called as underscore a named memory location called underscore a, and it is going to store the value of 8. I can define another variable like this. B8 is equal to 9. So here I'm defining another memory location, named memory location called as underscore B8, and it is holding the value 9. And then I can say Z is equal to underscore A plus underscore B8. Now the variable name called as Z is going to hold the result of adding the variable values of underscore A and underscore B8. I can just use the print statement to print the value of Z. Now you can see that 8 and 9 have been added and the result of 17 has been stored in the variable name called as Z. So that is about variables. As I told, it can start with a uppercase letter or a lowercase letter or an underscore character. And we cannot use keywords as variable names in Python. So let's see what will happen if we use keywords as variable names. You have a keyword called as lambda in Python. So if I say lambda is equal to 7, you can see that it's giving me invalid syntax error, because lambda is a reserved word in Python and you cannot use it as a user-defined variable name. Now let's see about assignment statements. What is an assignment statement? Assignment statement is something which has a variable on the left-hand side and an expression or a value on the right-hand side. Say, for example, I can say A is equal to B into 3.14. So this is an example of a assignment statement. That is, I need to have the value for B. Then I can multiply the value of B with 3.14 and the value can be stored in the left-hand side variable name called as A. So I can give a value for B and then I can say A is equal to B into 3.14. So now the value of B is multiplied with 3.14 and it is stored in the variable name called as A. You can see that Now the variable name called as A is holding the value of 12.56. The next one is next thing which you have to remember is about operator precedence. Whenever we use operators, like we used B into 3.14, B has to be multiplied with 3.14 in this in the right hand side in this given statement. Whenever we have operators like plus, minus, or multiplication operator, or division operator, or exponentiation operator in an expression, we have something called as operator precedence. So operator precedence is nothing but the order in which the operators get evaluated is called as the order of precedence. So based on this operator precedence only, when you have many operators in an expression or a statement, the operators get evaluated. And in Python, the order of precedence of operators is first preference is given to parenthesis, and then exponentiation, and then multiplication, division, and the modulus operator. And then we have addition and subtraction. And whenever you have, whenever we have to follow associativity, the associativity is left to right. Say, for example, if I have a statement like this, A is equal to 2 plus 3 plus 5 into 6 exponentiation operator 2. So now the value is calculated. Here you can see that you have different operators here. One is parenthesis, and then addition, you have multiplication, and then you have exponentiation. So when I try to print the value of A, I get the value as 185. So how is this 185 got calculated? As I told you, first preference would be given to parenthesis. So first 2 plus 3 would be added and the result would be 5. And then the next preference would be given to exponentiation. So here 6 squared would be 36. And then you have next preference would be given to multiplication, division, and modulus operator. We have multiplication here. So you have 36 into 5. 6 square is 36. 36 into 5 would be 180. And already we added 2 plus 3 because it was inside parenthesis. So 2 plus 3 is 5. So 180 plus 5 would be 185. So this is how operator precedence happens in Python. Next, we'll see about the different types of literals in Python. Literal is nothing but a raw data which is given to a variable or a constant is called as a literal. In Python, we have different types of literals. Number one being numeric literals. This numeric literals are further classified into integer literals, floating point literals, and complex literals. Under integer literals, we have different types of subcategories like decimal literals, binary literals, octal literals, and hexadecimal literals. Under floating point literals, we have different categories like fractional literals and exponential literals. We also have string literals and Boolean literals in Python. Apart from this, we also have the various literal collections in Python. There are 4 different types of literal collections, namely list, tuple, dictionary, and set in Python. First is integer literals. Integer literals are nothing but the numerical literals that are 0, positive, or negative natural numbers. That is, those literals which don't contain any decimal points are called as integer literals. So there are different types of integer literals like decimal literals, binary, octal, and hexadecimal literals. So for example, if I say A is equal to 986, it is an example of a positive number. I can say B is equal to minus 789. It is an example of a negative natural number. So if it is decimal literals, it contains the digits from 0 to 9. The base for the decimal values is 10. And we have binary literals, which contains only 2 digits, 0 and 1. The base for the binary values is 2 and it is prefixed with 0B. Say I can define it like this. So this is an example of a binary literal. It is prefixed with 0B in Python. The next one is octal literals. It contains the digits from 0 to 7. The base for the octal values is 8. And in Python, such values are prefixed with 0 and O. So I can define something like D is equal to 605. This is an example of a decimal literal. I can define something like this. So this is an example of, this is prefixed with 0 and O. This is an example of octal literal. E is an example of octal literal. And then I can define something like this. So hexadecimal literals contain the digits from 0 to 9 and alphabets from A to F, capital A to F. So here F is an example of an hexadecimal literal. So I can print all of them using a print statement like this. So you can see here that when I try to print C, E and F, which is actually an octal literal, a binary value or a hexadecimal value, the decimal values actually gets printed. Okay, so the decimal values of the octal value is converted to decimal and the hexadecimal value is converted to decimal, and the decimal values of all of these literals have got printed now. The next one is floating point literals. Floating point literals are those literals which contain decimal points. So floating point literals are of two types. Number one is fractional literals and number two is exponential literals. Fractional literals contain both whole numbers and decimal points. Say I can define something like this. G is equal to 56.98. This is an example of a fractional literal. It contains whole number 56 and a decimal point also. And then the next type of floating point literal is exponential literals. Exponential literals are represented in powers of 10. The powers of 10 is represented by small e or capital E. An exponential literal basically consists of two parts, namely the mantissa and the exponent. Say, for example, I can define something like this. So H is equal to 2.789 E5. So here the digits before the symbol E in an exponential literal is known as mantissa. In computing, it denotes the significant digit of the floating point number. So here 2.789 is called as the mantissa part. And the digits after the symbol E in an exponential literal is called as exponent. It denotes where the decimal point should be placed. So 2.789 E5 means 2.789 into 10 to the power 5. So if I try to print these two literals now, you can see their these floating point literals and their values getting printed here. The third type of literal is complex literals. Complex literals are represented by A plus BJ format, where A is the real part and the B part along with J is called as the imaginary or the complex part. So here J represents the square root of -1. So I can represent a complex literal like this. X is equal to 6 plus 3J. So this is perfectly valid literal in Python. This is an example of a complex literal. Here 6 is called as the real part and 3 is called as the imaginary part. Suppose I want to print the real and the imaginary parts. I want to get the values, then I can do it like this. So to get the real value of the complex literal, I can use x dot real, and to get the imaginary value of the complex literal, I can use dot imaginary dot imag. The next one is string literals. String literals can be created in Python by enclosing the text or the group of characters in single quotes or double quotes or triple quotes. So if you use triple quotes, it allows us to create multi-line strings. The meaning of multi-line strings is strings which goes on for multiple lines are called as multi-line strings. Say, for example, I can say so here I have enclosed this text, the group of characters in single quotes. I can enclose the group of characters in double quotes like this. This is also an example of a string literal. I can create multi-line strings by using triple quotes like this. So finally, I have to close the multi-line string by using a set of triple quotes. And then press an enter. Now you have got the command prompt again. So if you try to print it, print the multi-line string which you have created, you get the multi-line string which you have stored in the variable I. The next type of literals is Boolean literals. Boolean literals are used for comparison, and based on the condition which is being checked, we'll get only two results, either true or false respectively. Say for example, I can say u is equal to x equal to 5. I'm checking whether x is equal to 5 or not. So the condition which is being checked is I'm checking whether x is equal to 5. Then I'm trying to print the value of u. So it is giving me false because x equal to 5 is false. And then again, I'm checking another condition here. 1 equal to 1. Then I'm trying to print the value of k. So it is printing true because 1 equal to 1. The condition which is being checked is true here. So that's why it's printing the value of true. So this is an example of a Boolean literal. So they can store only two values, either true or false. The last type of literal is in Python, we have one special literal called as none, which is used to signify that a particular field is not created. Or Python will print none as output whenever we try to print the variable with no values assigned to it. So we also use none for end of lists in Python. Remember that it is capital N-O-N-E and it is not small n-O-N-E. So I can create this literal, none literal like this, L is equal to none. So here I have created this special none literal here, and then I try to print the value of L. So it has now printed the value of L as none.